again. I'm continuing my series on documenting the differences between the Hopper programming language and the other familiar semicolon and curly brace languages, specifically the more modern ones like C# and Java, but it applies if you have knowledge of C++ and C as well. In this video, I'm going to talk about what in C or C++ are preprocessor directives. So if def and a symbol, or if and def and a symbol. It turns out these are actually quite a useful feature in this environment, since we're trying to have a single platform that can target multiple different architectures or hardware layouts. So changing the functionality that's available based on what we're targeting is easily achieved, neatly achieved with these if-defs. Unfortunately, they're not as powerful or as consistent as the way they work in C or C++, or even in C#. And that is because they're not really preprocessor directives, because strictly speaking, Hopper doesn't really have a preprocessor, even though one of the elements of the tool chain are 5 applications that run in series. So it first runs one called preprocess, then it runs one called compile, then it runs one called optimize, and then code gen, and then optionally you can disassemble the output so that you've got something for the debugger. So the first 2 stages in the tool chain are called preprocess and compile, but they're actually misnamed because the one is the first stage of the first pass of the compiler, and the other is the second pass of the compiler. So the first pass of the compiler compiles at the global level to pick up all the definitions of globally defined entities like global variables, namespaces, or units, whatever you want to call them, methods, properties, functions, that sort of thing. So you can think of it as staying outside of these curly braces. So the first pass only picks up the definitions of the methods and properties and functions and things, and doesn't go inside them. So during the first pass, it cannot see inside the methods, so it won't see these directives. It'll only see directives that are at the top level. Also, there's a limitation. You can only define these at that top level, at that global level. You can't define one in here. If I try and define a symbol over here, the compiler should pick it up and stop me from doing it, which it does if you look at the bottom of the screen. Okay, so you can define a symbol like that, and they're global. So if I defined, it doesn't matter what the order is that they're in either. For stage 2, that is. For phase 1, if it hasn't encountered yet, it doesn't exist. So if I'm compiling for the 6502, this is the main system file that gets included, which includes all the other system files. And right at the top, it's got a symbol for Hopper 6502. So at this level, we can include and exclude things like that. And if we go and look at some of the functionality that uses this, let's look at the time unit. So inside time, if it's on Hopper, if it's not on Hopper, if it's on Windows, it's actually the delay method is built using Hopper code and the Millis API. Problem is, on Hopper, if you define tiny Hopper, then you don't get reference types, and believe it or not, long is a reference type. And without a reference type, you can't do this functionality. So on Hopper, the delay is actually implemented as native assembler in 6502. Another reason, so that's one reason to do it, is because you're missing some functionality. The other reason is the actual time taken to execute this code on the 8-bit machine is significant, so it would affect the time of the delay. So that's another reason that delay is implemented in native assembler on the 6502. But there you can see the use of an ifdef. If you're on the Hopper system, then it's a system API. If not, if you're on Windows or maybe on a microcontroller, then it's this API is then written in Hopper itself. So that's quite common. And there's different reasons for doing it. In this case, it's performance and the possible lack of having the long type available. Another good one to look at would be characters, the character unit. So many of these little tiny functions are implemented in assembler on Hopper. And part of the reason for that is up to this point, I'd never bothered. I'd always had them written in Hopper because wherever I was running Hopper was fast enough, and it didn't affect performance. So this was done primarily for performance. So they're way faster if they're just system calls than if they're compiled as Hopper and executed as Hopper VM functions, all these little functions. So it's more portable if they're in Hopper. It means I don't have to write a Windows version and an ESP32 version and an RP2040 version, etc. But I get a performance hit because these are used by the string APIs. And the string APIs are the same. So it's just it gets out of control. And then the reverse. So this is actually in Hopper on both, but all the others, these have all been written as assembly language for the Hopper platform. I'll show you what I mean by the strings. So if we go to the string unit, there's a lot of ifdef as well. So in some cases, it was easier to, for a function that's not necessarily used a lot, it was easier just to write it in Hopper than to write it in assembler on the 6502. So that's what this is. But in other cases, and that's true as well, in other cases, performance mattered, and it was relatively easy to write the API in assembler on the Hopper machine. So for contains a character, for example, it is a system API on Hopper. So that one's written in assembler. This one's still in Hopper. This one with the character is written in assembler. The one with the strings are written in Hopper, just because it's actually quite a few hundred lines of assembler to do that. And index of is the same when it's looking for index of a character rather than index of a string. They're written as assembler on Hopper, while they are still on Windows or on ESP32, they're still written in Hopper. So this is all done with ifdef and these conditionals. And as you can see, these ifdefs are all at the global level, so they work. And the one exception that I started with was the one that was in uint, where I've got it inside the method. It's not at the global level. But even this, when it's inside the method, it has to be inside the same block, like that. So you can't cross a block boundary with a define. The compiler won't allow you to do that. So these are limitations of this feature, but they do make it easier to implement, and it also it's like good practice as well. You end up with less mistakes. It's a little bit of a limitation, but that's how it is. You've seen these directives, Tiny Hopper, and Tiny Hopper is a version of Hopper for the 6502 that doesn't include reference types. So it's a version that doesn't include the heap. So instead of being about 20K, the Hopper virtual machine on the 6502 is about 20K of machine code. Tiny Hopper is about 6K of machine code, so it fits within an 8K ROM, but it doesn't include reference types, so it doesn't include strings, doesn't include a heap manager, garbage collection. To learn more about that, go and watch the video on my 6502 playlist or in the internals playlist. Thank you for watching.